All right, 3.3, probabilities using counting methods. All right, so probabilities will be like it was before, right? So we'll get into that. But counting methods, we're actually going back to like the last chapter there, right? That was all the stuff we did with like factorials and combinations and all that kind of stuff. So now we're going to be figuring out probabilities using that stuff. So you know how we were doing like number of ways something can happen? Well, now we're going to be doing like number of ways over total number of ways. So that'll give us our probability. So here's an example. So it says, oh my God, it's going to start already. I think it's because this class is a little bit bigger. It makes my computer lag because you got more people in Zoom. All right, so it says Ari, Ben, Cam, and Dan have booked a flight to Florida. The plane has 4 seats in each row with an aisle down the middle. The boys have booked all 4 seats in the same row. We want to know, what is the probability that Cam and Dan will sit beside each other on the same side of the plane? All right, so here's the idea. Number 1 says develop a sample space of the number of ways the boys can sit together. There should be 6. So here they are. So we have, I'm going to use these letters, right? A, C, D, and F for like the seat numbers there. So we'd have, oh, actually, no, sorry. I won't use those. They have F there. I'm going to use A, B, C, and D for the names of the kids. So we'll have, all right, so you got A, B on one side, and you could have C, D. You could have B, A, and D, C. You could have AC and B, or sorry, and BD. You could have AD and BC. You could have BC and AD, BD and AC, and then CD and AB. All right, whew. All right, so that would be it. It's always a little annoying with the sample spaces, but in the end there, oh, sorry, no. Yeah, sorry, my bad. We can see that this one, I shouldn't have put that one there because this one doesn't matter, right? Because we've got BA and is the same thing as AB. So in the end there, we would just have these different combinations, right? There would be more if it was a permutation and order mattered, but BA and AB were the exact same thing, so that one didn't matter. So there's really just these 6 ways, right? 1, 2, 3, 4, 5, 6 different ways that they could be ordered. Okay. So now, all right. So it says, how many of those ways has Cam and Dan sitting together? So really just this way and this way. That's the only 2 ways that happens. So in the end there, we've got, yeah, just really 2 ways. What's the probability Cam and Dan sit together? Okay, well, if there's 6 different ways that they can, and they only actually sit together in 2 of those combinations, well, then that would really be a probability, so P, of 2 over 6, right? So 2 is my favorable, 6 is my total, just like from last lesson, right? And then that could be simplified to 1 over 3. So that would be right. You could say 1 over 3 probability, or you could also say that that's the same thing as 33.3%, right? If you went 1 divided by 3 times 100. Okay, so now what are the odds that Cam and Dan sit together? Okay, so the odds, remember, is favorable to unfavorable. Okay, so favorable in this case would have been, so if I'm looking back at 1 over 3, then the favorable was the top, right? So that would have been 1 ... and then everything else. So everything else, all the other ways, would be 2, right? So it's 1 to 2 odds, right? 1 chance that they will sit together to 2 chances that they won't sit together. All right, moving on. Okay, so we got 10 students have volunteered to put on a talent show at a retirement home, but only 3 are allowed to go. Victoria really wants to go since her grandparents live in the home. Unfortunately for Victoria, each student's name will be put into a hat and 3 names will be drawn at random. Victoria wants to know what her chances are of her name being drawn. So A says, is this a fair way to determine who gets to perform at the retirement home? In other words, is Victoria just as likely to be drawn as any other name? So what they're getting at here is there's an idea of like fair games, and this is a fair game, right? That it is just as likely that it's fair for everybody in that. So yes. Does the order in which the names are drawn matter? So what hint does that provide in helping you choose which function to use in your calculator? So no, it doesn't actually matter on the order. And what that means is there's a group, right? It says that only 3 are allowed to go, but I don't care what order they go in. It's not like it was where there was like first, second, and third place, where there was so many that could be first, and then after you chose that, there was so many that could be second, like a permutation. This one doesn't matter. There's just 3. There's just a group of 3. I don't care about the order. So this one, you just say no. Doesn't matter on the order. And this is going to help us because we are going to use a combination, not a permutation. All right, so C. How many ways can the 3 names be drawn from the hat? All right, so this is really a question from the last chapter there. There are 10 kids to choose from, and we are going to choose 3 of them, right? That's how many you can go. So it's just really 10, choose 3, and you can just write into your calculator. 10, choose 3, 120 different possibilities there. All right, next one. To determine Victoria's probability of being drawn, always assume success, right? To successfully draw Victoria's name, we use 1C1, and it says how many ways can the others be drawn? So what the idea is here, if I want to figure out how many ways her name can be drawn out of those 10 people, well, what I can do is I can say, okay, of the one Victoria, I'm going to choose that one Victoria, which is kind of silly because that really is just one, right? You're just saying there's one way that can happen, of just picking Victoria's and actually choosing Victoria's. That's it, right? So I'll call that 1C1 for how many ways to choose her. But what I have to account for is how many ways can I choose everybody else? Because that's going to be part of it, right? Like she can only be drawn one way, but everybody else could be drawn. Well, now there's only 9 of them, so I'm going to have 9, and I'm going to choose. Well, now there's only 2 spots, so we're going to multiply those because it was number of ways to pick her, and multiply it by the number of ways to pick everybody else, and that's how many ways it can all actually be drawn. Okay, so if I want to figure out what's the probability of her name being drawn from the hat, then here's the idea, right? This formula right here, that's what we've been doing, right? This is just favorable over total, we were saying. And now we're saying number of success over number of all outcomes, same thing. But our number of successes, well, that's going to be the number of ways to pick her, and then multiplied by the number of ways to pick everybody else. That will be like the number of ways that I can pick Victoria, right? So that's my top, that's my favorable. And then the bottom is just going to be the number of ways to draw the 3 names. All right, so in the end here, this is just going to be the probability. So P will be 1C1, so Victoria, like picking her, times the number of ways we can pick everybody else, so 9C2, and then over, right, the total, so everybody else. So in total, I don't care about like Victoria, I don't care about anybody else. I just care that there's 10 of them. So we've got 10 people, and we're going to choose 3 of them. So if we put all of this into our calculator, we would get out, well, you can do this and go one at a time and go 1 times 36 over 120. So you'd get 36 over 120, which would be the same thing if you just divided those. You'd get 0.3, which really is, remember, 0.3 just multiplied by 100 would be the same thing as 30%. So there's a 30% chance that her name will get picked. How are you guys doing? I know this one's definitely tougher than it was yesterday, right? More going on. All right. So F. Now it says, suppose only 8 students volunteer for the talent show and 3 students are randomly picked to go. What are Victoria's chances now? So in this case, it'll be the same thing, but we're going to change it up a little bit. So we'll say, okay, the probability will be, I'm still going to say 1C1 for picking her. I could also just call that 1, right? But either way. And then I'm going to multiply it by, well, if there's only 8 that are being picked, then after I picked her, there's only 7 to choose from. So that'd be 7C2. Right? This is the number of ways that she can be picked. And then that will be over the number of ways that anybody can be picked. So that'll be just everybody, 8C3. And if you put all that in, that would end up being 1 times 21 over 56, which would be the same thing as 0.375, which could also be called 38%. Okay, next one. Because only 8 students volunteered, the teacher decided only 2 students would be selected to go. So what are Victoria's chances now? So do it all again, but just change it up a little bit. The probability would be her, 1C1, times everybody else. So there's 7. But now we only have 1 more spot, right? Because only 2 are going now. So it'd be 7C1 for my total ways to pick her up top. And then on the bottom, it would be everybody, so 8 of them. And then we're going to choose, but only 2. Okay, and in the end there, putting it all in, we'd end up getting 0.25, which would be the same thing as 25%. All right. Okay, Jamal, Ethan, and Alberto are competing with 7 other boys to be on the school's cross-country team. Only the fastest 3 runners in a trial race will represent the school. What are the chances or probability that Jamal, Ethan, and Alberto will be represented or will represent their school? All right, so probability will be, okay, so on the top here, we're going to say, well, of those 3 boys, we're going to just say, okay, it's going to be 3, and we're going to choose all 3 of them. All right, so of those 3 boys, we want to choose all 3 of them. You also could have just called that 1. There's only one way for that to happen, right? There's only one way to say, okay, we have 3 boys and we're going to choose all 3 of them. So like I said, again, that could have been 1, right? There's only one way that can happen. But then on the bottom, it will matter, right? We're going to say, well, there really was 10 people to choose from. And we're going to choose 3. So again, this is the number of ways that we can choose those 3 boys on the top. And the bottom is the number of ways that we can choose any 3 boys or any 3 people, right? So putting all that in, you'd end up getting 1 over 120, which would be the same thing as 0.0083. And then just careful on that, right? You'd want to multiply that by 100 or move the decimal place 2 times. And that would be the same thing as 0.83%. Okay. Next one. Suppose Zachary is trying out for the team. So there are now 11 runners. What's the probability that 3 boys of these 4, or sorry, what's the probability that 3 of these 4 boys will represent their school? Okay, so in this case now, we're saying, so of those 4 boys, right? So we'll say the probability is equal to, there's 4 boys to choose from that I want to win, right? That I'm saying like that's what I'm hoping for. That's my favorable. There's 4 boys, and I'm going to choose 3 of them, right? So hopefully 3 of those 4 boys get, like, that's how many ways that can happen. And then again, over the total. So in this case, though, just remember there's 11 now because we added 1 more. So there's 11 people in total, and we're going to choose 3. And that's really it. So then that would just be 4 over 165. which would be the same thing as 0.024, which would be the same thing as 2.4%. Okay. Determine the probability that in a family of 3 children, at least one is a boy. Okay. This, you guys know the questions that we did before where there was like those cases where it's this word here, like at least, right? We did those cases where it's like, okay, if there's at least one boy, then I'm going to have to do this for 1 boy, 2 boys, and 3 boys. And we're going to have to add them all together, right? That's the idea here. We're going to add up all the ways that this can happen. So, okay, so let's do this way. So we'll say that you could have 1 boy, or you could have 2 boys, or you could have 3 boys, right? That's all the ways that this could happen. So really, I think on these ones with the number of kids, I think the best way to do it is actually just to like write them out. There's not that many, so we can kind of figure out how many ways this could happen. So if we did a sample space on this one, you could have boy, girl, girl. All right, that's one of the situations that could happen, to have 1 boy. Another one would be girl, boy, girl. All right, that's another situation that could happen. Or you could have girl, girl, boy, right? So 3, right? There's 3 different ways that could happen. Okay, so now for 2 boys, be very similar. We'll say, okay, you could have boy, boy, girl. You could have boy, girl, boy, or you could have girl, boy, boy. But again, there's 3. That's it. There's 3 different ways that could happen. And now this one's pretty easy, because how many ways is there to have all 3 boys? Well, there's only 1 way. We can have boy, boy, boy. All right, so there's only 1 way that could happen. So 1. So now what we do is we add up all the ways, right? So so we go 3 plus 3 plus 1. So there's 7 possible ways that could happen. So you'd say, okay, there's 7 favorable. So here, I'll write the probability. So I'll say probability is equal to 7 favorable. I don't know if having 3 boys is favorable, but so 7 favorable over, and then what about the bottom here, right? So the bottom, we'll have to figure out. Here, I'll write it over here. So if you thought about it this way, that, okay, you've got 3 kids. Well, there's 2 possibilities for the first kid, right? There's 2. It could be a boy or it could be a girl. The second way, there'd be the second kid, you could have boy or girl. And the third kid, you could have boy or a girl. So in total, there'd be 2 times 2 times 2, right? You multiply the number of ways that can happen. So in total, our bottom, like our total would be 8. So what I can say there then is that 7 over 8 would be the same thing as 88% if I just divided those and multiplied by 100. So there is an 88% chance that at least one of the kids will be a boy if you have 3 kids. Okay, so now that was the direct method. It might be easier to think about it that way, but the indirect method, we did those before, right? Would be, okay, so we could say, if we want to say at least one is a boy, the other way we could have done this question, that would have been a lot easier in the end, is you could say, okay, well, the only other thing we missed was all girls, right? So I could say the only thing that we'd have all left, I'll write this over here, would be like all girls. All right, so how many ways could you have all girls? Well, again, that would just be girl, 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 right? That'd be it. So there's only 1 way that can happen. So I could have said the other way too, right? If I was saying, what's the probability of having all girls? Well, the probability there would be, well, there's only 1 way for that to happen. So that'd be 1 over a total of 8. And then from there, I can see quite easily, okay, well, that's the probability of all girls, right? So then if I had the probability of just having like, anything else, right? Having 1 boy, well, that would be 7 over 8. So you could, like, if you're okay with this direct method, or sorry, this indirect method, it's sure a lot quicker. You don't have, we never had to figure out, all the different ways and add them up like we did in the direct method. But I know that this one could be a little, like the indirect method could be a little bit harder to think of. So up to you guys. Decide. You can decide which one you want to do. But yeah, all right, we're getting there. Okay, so the Scrabble tiles for Saskatchewan are placed in a cloth bag and drawn one at a time. What is the probability we'll draw the name Saskatchewan in that order? So we've got Saskatchewan that you just like in the order that you just one at a time. You end up like spelling the word Saskatchewan. All right, so probability here, we're going to say, so the probability is going to be, well, first off, let's figure out the total. How many ways can we rearrange those? Okay, well, we've actually done ones like that, right? Where you take all of these letters and we want to say, okay, how many ways can you rearrange those letters? So remember how we did that? We counted them all up. I said, okay, well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 12 letters. So if those letters were all different and I didn't care, like, and there was no repeats there, well, then there would just be 12 factorial, right? There'd be 12 factorial ways to rearrange those, right? There'd be 12 and then the next one would be 11 and then, 10 and all the way down, right? But what we do, because some of them I don't care, like, right? I don't care that S and that S. I don't care which S I have. I just care that's an S. There's two of them. So this is where we would divide by the repeats, right? 2 factorial we divide by. And then I look at my A's, right? So I've got 1, 2, 3 A's. So I'm going to divide by 3 factorial. And then what else do we got there? S is T. Is that it? Okay, I guess that's it. Yeah. Okay, so in the end there, if you put all that in, right, just into your calculator, then you'd end up getting this big number. You get 39,916,800. Okay, and then we're going to say, okay, how many ways is there for my favorable up top to spell Saskatchewan? Well, there's only one way. There's the way to spell Saskatchewan, and that's really it. So you just have, yeah. So that's it in the end. 1 over that number, and then yeah, and you could leave it like that. If you ended up going 1 divided by this, you'd end up with a really, really, really small number and it'd be hard to look at. I think this is probably the better way just to leave it like that. Okay. Okay, how are the probabilities different if the tile spells Saskatoon? All right, so let's do the same thing. Let's do it quick here. So you'd have P is equal to, I know it's going to be 1, just like last time for my favorable. But then my total, well, we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so we've got my total here. I'll do it maybe over here. Say 9 factorial over, and then my repeats going on. I've got 2 S's. So I'm going to go 2 factorial. I've got 2 A's, so another 2 factorial, and 2 O's, so another 2 factorial. So in the end there, all of that would be equal to 45,360. So quite a lot better chance of that. Last one. All right. This one's a little tricky. You won't have to do too many of these, but I'd like you to get the idea of it anyway. So it says there are 18 exercise bikes in 3 rows of 6 bikes each. Allison, Brett, Carol, Doug, Erica, and Franco each call the gym to reserve a bike. What's the probability that they will be in the same row with Allison on one end and Franco on the other? So here's 2 possibilities that maybe a student has done. They're both correct, but I just want to show you why they're correct or how we got those numbers, right? So in the end, to begin with, what we're doing on both of these is this is my favorable and this is my total. All right, so that's what we're after there. And I think this will make a lot more sense if we actually write them out. So it says there's 18 exercise bikes in 3 rows. So I want to actually write those out. So let's go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. All right. So now what we're going to do is we're going to kind of do what we did before with those blanks, right? Like in our last chapter. So I'll say, okay, so they told us that we want to have Allison on one end and Franco on the other. All right, so let's just look at the first row for a second and say, okay, if it has to be one of those two on the end, right? So if I look at this first spot, well, there's two ways that can happen, right? It could be Allison or it could be Franco. They could be in that spot. And then on the end here, it has to be the other one, right? It has to be, if it wasn't Allison, it'd be Franco. If it wasn't Franco, it'd be Allison. So that's for that one. And then on the inside, we're going to have everybody else, right? So you'd have on the top there, you'd have, everybody else from these guys, from their friends, right? So they all want to be in the same row. So in that case, you'd have 4, like everybody else, everybody left, right? After we chose those two. So you'd have 4, 3, and 2, and 1. Okay, so now that I have that, let's say, okay, and then once I've done that row, you've got everybody else. So you've got everybody that wasn't these 6 people. So that would be, we'd start at 12, right? There's 12 other people. And then after I chose them, there'd be 11. And then there'd be 10. And then keep on going, right? There'd be 9, 8, 7, 6, 5, 4, 3, 2, and 1. All right, so I think we're at the point that we can start making sense of how somebody put this into their calculator, how they did this. So what we got going on, this 3 has to deal with the fact that it could have been this row, or this row, right? It didn't matter which one they were in. So they just figured, like, we're going to find these probabilities up top, or sorry, not probabilities, the number of ways that the top can happen. And then we're going to multiply by 3 because it could be any one of them, right? It's kind of like the cases, right? There'd be like this case, and this case, but it'd be the same for each of them. So we just multiply by 3. So that's where the 3 comes from. Now the 2p2 part of it, that comes from the fact that it was this, right? 2 and 1, right? That was Allison and Franco being in the spots that they were in, right? And then the 4p4, which is the same thing as 4 factorial, right? That 4 factorial, that was this part, right? 4, 3, 2, 1. That was all the rest of the friends here in that row. And then the 12p12, that was everybody else, right? That was all this down here, right? 12 factorial or 12p12. That's counting all the way down. So that's the top. And then the total, right? 18p18. Well, that's the same thing as just 18 factorial. So that would be, if I just started up here and went 18, 17, 16, right? All the way down. That's if I don't care who any of these people are. We're just saying what's the total number of ways that any of them could be rearranged. So does that kind of make sense? I know it's confusing, but I think it's worth kind of talking about showing you like how that works there. Now the other one, so this one here is the same idea, right? I don't really want to write it all again, but it's the same idea, but we're only looking at one of the rows now, and just choosing that, right? So there would be 3. I'd still have to do this situation, and this situation. But there's only 3 because what we did is we just said, okay, well, this 12p12 up top would cancel with 12p12 on the bottom. So we'd end up having the exact same thing, but it would just simplify to that. Let's not look too much into it. It's I don't, just for the sake of time, I don't think I'm going to explain that one either. If you guys got your head wrapped around this one, I think we're good to go. Yeah, but that's it. So textbook questions are going to be, so it should be on the website there too, right? But it'd be page 159, number 4 to 8, and 10 to 12.